Welcome back, everybody. In this lesson, we're going to go over object-oriented programming in Python. It's a very important topic. So, even after the class, I encourage you all to revisit these video lectures um, as long as you have access to Canvas. I'll also share my YouTube channel as well. Okay. So, we'll learn about how to create a class in Python, and we learn few more concepts in object-oriented programming, and we'll also create our own object out of those classes. So let's start. Before we get into detail of OOP, object-oriented programming, so let's take a look at a real-world object. Okay, so let's take a car object for an example. Car as an object. So basically, all cars belong to car type or car class, and that's how we categorize those objects in English. So basically, the manufacturer creates a car following a concept of the car or the blueprint. So basically, all cars share like similar features like brand, model, win number, plate number, uh, many more. All cars perform actions or behaviors like driving, accelerate, braking, steering, okay, and much more. So we basically collectively call features data and collectively call actions or behaviors functions. So basically, together, this data and function uniquely identify a car in basically real world. Okay. So car type or the car class. Okay. And the manufacturer simply follow this car class, the concept of the car, to make cars. Okay. So basically, manufacturer uses a plan or a blueprint to make cars, not boats, right? Not trucks. They make cars out of a car blueprint or plan. Okay. So it is important to understand that this blueprint is contextual. So basically, different entities going to interpret the concept of car close but different um, context, different perspectives. Okay, like some data may be common, but let's identify some of those. Okay, so to general publics, so the English speaking public or any other language, we know that car in that particular language, right? We identify, it's how we identify car in any of those language. For English, it's the car. Okay. For a manufacturer, basically there's a real template of car model, right? So they make cars out of following a real procedure. Okay. For DMV, Department of Motor Vehicle, they attach an owner to a car, and that's how we register the car. And for insurance, they not only attach an owner, they also attach drivers too. Okay. So now you can understand that the perspective of car is depend on the context that we use. So basically, we follow this template and create car objects, right? So each car object is unique because they have either plate number or a VIN number. Okay. Actions may be unique too, like the way doors open, um, how the drivetrain works. Like for example, if you take an electric car like Tesla, well, it's completely different. as to the drivetrain of um, gasoline powered cars, right? So those things. So if you take a unique car object, it has a unique set of data and functions. So this is the way every basically real world object govern. Basically, each real world object has a set of data and set of functions attached to it. Okay. So since we learned real world problem in programming, okay. So if we take a car manufacturer, okay. So car manufacturer logs each car it makes or uses a software to automate the production pipeline, right? So that's how basically. So these are examples, okay. So car maker may want to interpret a car in its software package, basically simply to follow the automated pipeline, okay, or logging purpose, right, in their databases, like how they record each car they make, okay. So DME records the cars and their owners, okay. A gaming company model a behavior of a type of a car, right, and they even use real names, real car names in there, right? So they want to model a type of a car. An insurance company may track cars and drivers together in their, tracking, insurance information tracking. Okay. So, all right. So let's now identify. So far we have been writing functions to solve problem. Now we are kind of getting into a different perspective of attaching data along with function that is belong to a single unit called object. Okay. So let's talk about why the functional solution is not that feasible. Okay. So let's take an example of throwing a cubic dice. Okay. And we know that we can use six random numbers and random number modules, and we can model throwing a dice. Okay. Well, there's a problem now. What if the dice is different? The dice has a different shape, right? It can be like pyramid shaped dice, or like a 3D different to cubic, like octagonal, something like that. So there could be like more than six faces to the dice. So what will happen if our dice is like that, right? So now we are having to rewrite our code because we wrote the code for specific six phase cubic dice. Now our dice is like, let's say, pyramid shape, and then it's four sides. Now we have a problem because our original solution for rolling the dice wouldn't work with this new dice. Okay. So basically relying only on the actions or the functions, basically it's less reliable. Okay. So, and it also doesn't make any sense. For example, if you take a microwave and then the action is basically cooking, but like when we refer to cooking, microwave cooking, it's kind of odd to refer to that because we are simply completely ignoring the actual microwave object, right? So if we consider both the action and the object that the action related to, then it's more reliable. And you'll see that object-oriented programming we achieve that. Okay. So we need to basically consider not only the action but data too. Okay. So basically need to consider data plus function together. And when you do that, basically that's the object. Okay. So basically object represent unique set of data and functions. So unique object represent unique set of data and functions. So instead of just writing a role, okay, we can create a dice object and the method role attached to it. Okay. All right. So that means we can write one dice class to represent many dice objects. Okay. So now sort of in our class, we categorize all type of, we can categorize all the type of um, shapes of dice into that. And then we can basically, so that dice class we wrote represent entire class of dices, and through that we can actually pass this number of side parameter into the role, um, that call, and then create different or model different dices. Okay, dice object. Okay, so that's the idea of basically core idea of having a blueprint to create objects, in this case a dice. Okay. All right, so let's talk about a little bit about object. So an object has its own data. Okay, so we call it, basically those data represent the state of the object, right? If it is a dice, okay, so it's how many side does it has. If it has 6 sides, the state of that number of side is 6. Okay, so like that. Okay, and if the object has some functionality associated with it, and basically we can implement them, and that basically those functions represent the behavior of an object. Okay, so any object associated with its own functions. So commonly state plus state and behavior together, we call them attributes of an object. Okay, another name is actually members, uh, if it is in programming, basically, specifically. Okay, so the definition of a software object is basically, software object is a bundle of related state and behavior. It's a software bundle of related state and behavior. Okay, so what is a class then? Well, class represent entire population of, like, objects in the same category. Okay, so represent a category of objects in real world, and it models the real world object in software world. Well, simply we solve real world problem in software world. Okay, so it models the state and behavior of a real world object in software world. So definition of a class, basically class provide the blueprint or the prototype or the template from which we create objects. Okay, so basically if in an interview, if someone asks, okay, how do you define a class, what is a class in object oriented programming, you can perfectly give this answer. A class provides the blueprint from which objects are created. All right, here are some terminology related to OOP. Okay, like I said earlier, method and states together, we call them members of a class. Okay, they are members of a class. Okay, an object of a class is called an instance of a class. Okay, of the class. Members unique to an object is called instance members. Okay, members common to all all the entire class is called static core class members. Okay. So notice the difference. Instant members, they are unique to a particular object, so they are belong to objects. On the other hand, there could be members that are common to all the population of the, the objects, basically for the entire class. Okay. All right, so let's learn some few concept in object-oriented programming. First one is encapsulation. Okay, so an object stores its state in data, field, and variables. Okay, so it exposes its behavior as functions method. So object has its own data, but it exposes its behavior as functions, or we call them methods too. Okay, so basically methods operate on object's internal state and facilitates object to object communication. Basically, it those methods facilitate communication between the object and the real world. Okay, outside basically. Okay, so packaging in this way both data and functionality together is called encapsulation. Okay, so packaging data together with methods that manipulate those data into a single entity. That entity is the object called, that process is called, that concept is called encapsulation. So basically encapsulation means you confine few things together. So here the few things are data and methods. Okay, and then that whole thing represent the object. So the object acts like the capsule. Okay, information hiding. Okay, so we consider usually data are private. Okay, so and then we should prevent easy public access. Okay, so basically when we solve problems using OOP, the user, basically data is hidden to that user. Okay, so that process is called information hiding basically. So basically controlling the outside access to attributes, basically data and both methods and data, thus hiding them is called information hiding. Okay, so we call, sometimes we call abstraction too. Okay, information hiding. So unlike Java and C++, Python doesn't explicitly support it. Okay, so there are good reasons. That's how Python designers thought it. Okay, basically they thought, okay, so we're gonna make the programmer more responsible more here, not the language. So um, one can say that basically Java is more secure than Python. Well, it depends. Okay, so either language, if the programmer is careless, then security breaches can happen, right? So anyway, there's no explicitly handling mechanism on data privacy in Python. Okay, so if you know already Java and even C++, there's these keywords: private, public, protected. So those are the keywords to handle data privacy. Python doesn't have specific keywords like those. Okay, but there's a workaround to do this. Okay, so basically if you use names start with one underscore or two underscores, and we call them actually internals, we have seen it already. Okay, so we call them internal variables. They are basically they have restricted access. So basically from the client side, from outside, we don't have direct access to variables with uh, name starting single underscore, double underscore. Okay, so simply making them internal variables, we can sort of achieve hiding, but it's not perfect as well. Okay, and when we after we do that, then we can use getters and setters to allow access. So the accessing from outside makes sense. Like not that like if it is still secure, it's not doesn't compromise the data, then we will need to access the data inside, right? So some sort of access to data is necessary. So to provide that, we write separate set of functions. We call them getters to access basically. So another name is accessors. Setters basically set a new value to those variables, set them. So they are called setters, and the other name is mutators because it's a change. So they allow mutation, okay, to allow access from outside, okay. All right. So in Python, objects, basically to create objects, we need the respective class, okay. So we have already been doing that, right? So for example, when creating a list built-in function, we actually use the type constructor of list, right? So we use the list function, right? We use the list function, which is the type constructor of list class. Okay, so we have been using that already. Okay, so let's learn how now we can create our own Python class. Okay, so the syntax is basically start off with the class keyword and then the class name. Class name, as a standard convention, must start with the capital letter, okay, and a big capital letter. And if there's more decorating portions of the name, then we separate them with the underscore. And it ends with the colon. It's sort of similar to, it's actually a class definition, it's actually a compound statement. So it's similar to like a for loop statement. Like we have the keyword and the name and colon. Okay. And then the thing that we write inside comes after four space or one tab. Okay. And we need to have a docstring. It's basically, you can start the name of the class with represents because the class we write represent this thing, this entity. So that's what we have to write over here. Okay. And every class has this method initializer. Okay. And basically it initializes the uh, the creation of the class. Okay. So sometimes we call the constructor as well. Okay. And this function, this internal method tied to this name actually. So we call this internal method by calling this name. Okay. All right. So that's data initialization. And then if we have many functionalities, we actually put them afterward. Okay. All right. So this is sort of the syntax. Okay. So let's see an example. Okay. So note the naming, use of big letter as the first letter in the name, and use of underscore afterwards, and the docstring. Okay. And if you want to save this class separately in a Python file, then you have to name it like same class name .py. Okay. All right. So here's an example. So we are going to write a class to represent a rectangle. Okay. So class name, which is rectangle, and the docstring represent a rectangle. Okay. And if you have more, you can put more information there. And the class initializer method. Okay. And this is sort of the standard way of writing it. Okay. So self basically represent the object in context, actually basically the current object that we are uh, taking into account. So that self is This is not a keyword, can be any name, but usually everyone writes self over here. Okay. And these are the values we pass into our initializer from outside. Okay. So these are the formal parameters to initialize init method. And self.length, basically they are internal variables. Okay. So don't get confused. This is and this is, these are totally two different things. Okay. So self.length is the internal variable of length, and I'm simply assigning the value that I pass over here to that. Okay. We usually use the same name for that, so that makes it easy to identify them together. Okay, so self dot width equals width, and rectangle, it makes sense to calculate the area of a rectangle. So I simply added that over here, and it returns width times the length, which is the area of a rectangle. So let's check this out. It's going to quickly write this in our uh, file over here. Okay. All right. So I'm going to write it over here. Okay. So class, okay, rectangle, oops. All right. And you can write the doc string represents a rectangle. Okay. And first initializer, okay. So it's a function, okay. And sometimes we call it constructor, okay. And not only self, we're going to pass two more variables into that. So length, width, okay. And then we're going to use self. So self means current object, okay. So take the current object and access its length and assign the value to length, okay. And same for width, okay. So like that, okay. And then the second method that we gonna add, okay. So get, oops, get area, okay. Remember, when you name a method, always follow, use, take that verb to the front. So in this case, get area. You can use calculate area, also works fine. So return, okay, self dot length times width, okay, and that's it, okay. So it's our simple class to represent a rectangle. So let's create a rectangle object now, okay. So what I'm going to do is, it's slide number 15. So say um, 1 equals this, and here we pass the parameters. Remember I said earlier, this, the call to this method is tied to this name, so we are going to call that name now. So because these are internals, right, so we should not try to access these method from outside. So outside, this is the one that visible, okay. We also call the constructor. All right, so we pass the length, let's say 10, length is 20 and 10. I'm expecting, so this object, so I have now a rectangle object. So print, okay, so area, oops, okay, so I can now print, okay, oops, all right, dot, get area. Okay. All right. So let's quickly run this. Okay. So this one. All right. So you got 200 as the answer, right? So which is the correct answer. So now let's say we we want to change this once we create a rectangle, and we want to change the length and the width. Okay. So then we need to basically um, set them again. So def. So these are called setters. Okay. So usually, if it makes sense to change your data and allow access to your data, then consider writing them, because it makes your object or your class versatile. Right. So that's why you have to have that domain knowledge about the problem that you are solving. Okay. Sometimes this data should not be shareable, right? Should not be should not share with outside, which is the client or the user. Okay. So you have to have that domain knowledge about it. All right. So setters, I'd say getters. Let's first write the getters. That's the function that allow access. All right. So we start their name with get and get length. Okay. All right. And they don't take any arguments. They basically return length. Okay. And similarly, we can write the getter for the other width. Okay. All right. Okay. And how about setters? Okay. So, all right. So def get, sorry, set length. Okay. So now for setters, we need to get the new value, right? So let's say new length. Okay. And we're going to set it. Okay. So that means we take the self dot length, and we are going to set it to the new value. So now it's going to get changed. Oops. All right. And same way, we can write a setter for width as well. Okay. All right. So, okay. Width, new width, new width. Okay. All right. So let's try to do this and change the length and then recalculate the area. Okay. So I'm going to, so notice setters are, they don't return anything. Okay, so the setters are actually non-fruitful functions. All right. Whereas getters, they are actually fruitful functions. They return the value, right? So let's change. So this guy, this is the object. Okay. And dot set length. So we're gonna set it to, early it was 20. Let's make it to like 10. Okay. So now, so area, let's say, all right, so we're gonna print it again, the area, and we'll see that after change, all right, and it'll be 100. Okay. All right. So we got after change, it's 100. Okay. All right. So that's basically uh, accessing or changing. But for accessing, basically, let's say another part of the another program needs to access this variable, so then you can use the getters. Okay. All right. So let's go back to our um, slides. All right. So let's solve a problem now. Okay. So the problem is this. Okay. So create a class to represent a book as interpreted by a library. Okay. A book has a title, an author, an ISBN number, International Standard Book Number, checked out status. So those are the fields. All the books in the library carries the library name. So that's another field that is common to all the books. Okay. Two books are considered equal if their ISBNs are equal. Okay. So that's the convention. Okay. So it's basically going to compare two books for the equality. Okay. Use your domain knowledge about a book in the context of a library in implementing this book class. So that's sort of like think about what we do in simple terms, what we do in a library, right? So we have set of books, collection of books, and then we check out and then check in. So in this case, we only need to implement checkout procedure. Okay. So the problem says, all right, implement the book class, implement all getters, accessors, and setters, implement checking out a book. Okay. So here, so we don't have a physical library, right? So it's not, the process is not attached to a physical library. So just print a message if the book is available to check out. Okay, so we need to check that. Okay, so that's why we have this checked out status variable. All right, implement equality comparison of two books. Okay, so if the ISBNs are same, then we should say, okay, so the books are equal, same book. All right. So, and also create a helper function to create a list of books. Okay. Oops. Write another class to represent a textbook as interpreted by the same library. So we know that textbook has a subject, right? So textbooks are like, for example, if it is like Python, that's the subject of the textbook. So if it is physics, physics is the subject. So in addition to all those book features, textbooks has this additional feature called uh, subject. Okay, so let's try this one too. Okay, all right. So we are here. Okay, all right. So I'm gonna go to the problem. So this is the problem that we're gonna solve. Okay, so let me go over here. So um, all right. So the few things when you write a class, also consider writing the understand process. Okay, so identify the verbs in the problem description. There's a good chance them to be methods. Okay, so and then data. Okay, so data is going to be the variables. That's more often. Okay, so you can still write input. Okay, and that's going to be the data basically. Okay, so those are the data that you are going to initialize through input. Okay, so in this case, um, so we have this, right? Title and author, ISBN, checkout status. Those are our data. Okay, well, let's just write data. It's more clear, right? So data and well, behaviors, actions. Okay, and those are basically, so we need to write setters and getters, right? So those things, and getters. Okay, what else we need to basically um, write checkout. Okay, check out. Uh, that all. Let's see. Okay. We need to implement equality. Okay. So this operator basically, right? So we know that now for two numbers, it's simply comparing those two numbers. But how? What would we do for two books? So the convention is given, right? If the ISBN could be anything, but should make sense, right? See. Okay. All right. Okay. So this is good for now. And then after that, we need to write a class to represent a textbook also. And before that, we need to create a helper function to create a list of books. Okay. All right. All right. So let's write this one now. Okay. So, oops, class book. Okay. And oh, sorry, not there. And it has another variable. I think I forgot to write it over here. Library name. Okay. All right. So okay. So write def. So initializer init. Okay. Not only self, we have right title. Okay. We have name of the author. Okay. ISBN and checkout status. Okay. So checkout. Okay. All right. So this is basically checked out. Okay, that's fine. All right. Checkout status. So then basically, we need to write forgot to write the top string. Okay. Represent a book as by a library. Okay. All right. And here self dot title. Oops. Equals title. Okay. And dot author and self ISBN and checked out status. So let's make this default. By default, okay, let's make it true. Okay, so it's available for checking out. Okay, so well, let's see checked out status. Oh no, I'll take it back. Checked out status is basically that particular book is already checked out, so it is true now. So that means book but library don't have the book. Okay, so it's borrowed. Okay, all right. So you can now set that as well, but it has a default value. So if we don't pass this variable, so that means basically, um, well, let's make it false. Okay. So if we don't pass this, basically the book is available to borrow. Okay. All right. Equals that. Okay. All right. So that's the initializer. So okay, so let's add some setters. Okay, so we know we don't need to set the title again. Once we have a book, it's permanent. And also ISBN also. Okay, so checkout state, we should be able to change it, right? So say getters, we can write all of them. I'm only going to write, to save time, I'm going to only write just one, right? Get, let's say get ISBN, okay, equals, oh, sorry, and okay, return self ISBN, okay. All right, so that's getter. So setter, basically set checked out status, right? Right over here. All right. All right. So, oops. So basically, this is we need new value, right? So new status. Okay. So self status. Oops. Equals new status. Okay. All right. Now, so let's implement checkout procedure. Okay. So that's the behavior that we listed over here as in actions, right? So basically now, so this is setting the checkout procedure. Okay. So we're gonna now set the checkout procedure. Okay. Checkout. All right. So here, so basically, so check out the book. Okay. So what we have to do is we now if the book if we have the books library in the library, so that means if this is false, right, it's already checked out, no, it's in there, it's false, then we basically need to return a message to the user. Okay. So if, okay, so if this one, right, so we're checking whether it's false, right? So this only need, right, then basically return a string message. Okay. Message, let's say you can borrow it or something like that, or something like that. So we are just printing a message, well, like, acknowledgement. Okay. So let's say book is available, something like that. Okay. So, and otherwise, else, so that means it's false, right? So we need to return a message. Oops. It's not available. And when we do over here, we need to do one thing, right? So this, we are talking about one book. So we need to now, yeah, so this book gonna get checked out. So we need to change the status of this checkout status to false. Okay. Otherwise, it'll be always available, but we can still check out as well. Okay. All right. So this to true now. So we're gonna set this to true. Okay. All right. So, and that's it. Okay. So let's check out procedure. Okay. So let's check these. All right. So I'm going to, it's slide number 17. Okay, so I go over here, 16. So I'm going to create a book first. Okay, let's create a book. Okay, so all right. So I'm gonna create book one. Oops, what is it? I don't know. Okay, so book one equals book, and you pass those variables. So I'm gonna say it's a Python book, and it is Brad Miller, one of the author of our book, and then 1, 2, 3, 4 is the book number. So I'm gonna let the default take the checkout status parameter, which is going to be false. Okay, so that's it. So I'm creating an object. Okay, so let's anyway just print this one so I can actually show you some few more things to you guys. All right, so I'm going to print this. Okay, so we'll see not much. Okay, so see that. So this is the basically most primitive text representation of that object got printed. So we'll turn that into something meaningful later. So now what I'm going to do is I'm going to uh, check this book out. Okay, so print. Okay, book one. Okay, so check out. Okay, so let's try this one. All right, see what we get. The book is not available. Okay, so let's see which. Okay, we set this to false. Yeah, so this is if this is false. Oh, I think I made a mistake over here. Okay, if this is, yeah, if this is, okay, this should be true. This should be false. Okay, so this should be equals, should be not false. Sorry about that. Okay, so let's check this on now. Okay, so the book is available if this is right. So this is false, right? So, and to check for the false, then it should be not false. Okay, so we can also check directly as well. So like right here equals false. Okay, you can do that as well. Okay, so all right, so now we get, okay, book is available. So basically now the client can check it out or borrow it. Okay, so now let's print this, the status of the object. Okay, so what I'm going to do is I'm going to print. Okay, I'm going to print this. I'm going to print the checked out status of the book. Okay, so book one dot print that. So earlier, so this was when we create the object, it was um, false. Okay, now it should be true. Okay, so let's check on that. Okay, all right, it's true now. That means the book is checked out. Basically, the next comma, if you want the same book, it's not available. Okay, so now if I print, okay, so now I'm going to print again checked out status. Now I should get book is not available because I appropriately changed it, right? So not sales checkout, sorry. Okay. So checking out, let me write something right here. Okay. And now before, this is before checking out, right? So before checkout, and here it's after checkout. Okay. All right, so let's run it again. Okay, so we get after checkout, book is not available. Before checkout, book is available. We need to implement equality comparison of two objects. Okay, so let's create anyway. So let's create two book objects. Okay, so what I'm going to do is I'm going to create the same book object right here. Sorry. All right, as book 2. Okay, and let's basically print the comparison and see what happens. Okay, book 1, 2. You can also print book is. Okay, so let me just write it over here too. All right, and then over here, okay, so this should be that, and this is equals. Okay, all right, so okay, so let's run this. Okay, so see what will happen. Okay, so we got both false. But it's the same book, right? So we use the same set of parameters, but we've got books. Their equality is also false. Their identities are also false. That means basically these are two separate books. Okay, and here also, even though the data equals, well, it returns false. That's true, right? Because Python doesn't know how to compare two books. So the default is basically Python taking it from the how that object class represent equality. It is basically uh, any two objects, no matter how they created, they are basically unequal in Python as a standard. So Python take that. Okay. So simply we haven't written down the convention for the comparison in our class. So it's false. So excuse me, the created object in Python usually um, their their identities are different, even though the data is same. Okay, so that's by default it's false. Okay, so all right. So now how do we solve this? So we need to basically add the comparison procedure to our class. Okay, so we go over here. Okay, all right. So to do this, okay, so there are two internal methods that we have to use. Okay, so one is the the equality EQ def equality method EQ. Okay, all right. So this one, another book, right? So this should be another book, that is the book that we going to compare against. Okay, another book. Okay, and then we're going to basically, and then you can notice in PyCharm, the moment I put down this name came off. Okay, So it's overrides method in object. So it's saying that's okay. So object class has this you're going to learn about object class, which is basically the most the parent at the most top of the um class hierarchy. So object class has this method uh, implemented that returns, we saw that that returns false, right? So we are basically overriding it. See that overriding. Okay. All right. So um, right here, now what we have to do is basically implement the new equality feature, which is we gonna use the two ISBNs, right? So self dot ISBN equals, right, another book dot ISBN. Okay. All right. So all right. For that, we're going to use getter. Get, put that get. All right. Another book dot get ISBN method. Okay. And that's it. So this is our equality method. So whenever you override equals method, we have to implement our own hash method as well. So def. So that's the usual convention. Okay. So that's sort of the standard. Okay. So if we don't, and there could be complications later on. Okay. So we return. So user defined variables are immutable by default. Okay. So we need to carefully pick a parameter or data inside our object that is actually hashable and then return that. Okay. So I'm going to return hash value of okay self dot I can use ISBN because it's unique to object, and I can also use well, they say pick two of them and then put it in a tuple because tuples are also immutable objects. So then another hash value of, let's say, that maybe you can put a title there. What else? Yeah, title should be good. Okay, it's a string, so we can hash it, right? All right, see, again, also override comes, right? So object class uses, right? Object class, sorry about that. Okay, object class uses, um, sorry, object class define this hash method, um, but we are overriding it with our own way of writing hash method. Okay. All right. So now we can compare the two books. Okay. So we should get this is true. Okay. All right. So let's run it again. All right. We got it true. Okay. So that's after we added the functionality for equality. Okay. All right. So the others are not greater than, less than, but doesn't make any sense, right? So we don't compare books for the sizes. Okay. All right. So so I'm and finish off this problem. Okay. Write another class to represent a textbook as interpreted by the same library. Okay. In addition to all above, textbook has features, name, subject. Okay. So one thing we forgot was we forgot to add that library name. Okay. So that is actually belong to entire class. So it's actually a class variable. Okay. So if I put it right here, basically it only take, so it expecting a value to be initialized. So that means every time I make an create an object, it may expecting the name of the library. Instead of that, we were also already told that okay, so name of the library belongs to all the books, right? So we can make it a class variable. Okay, so so let's basically um, set it over here. Okay, so uh, name equals, let's say, Fremont, Maine. Okay, all right, and okay, so this is just a name of variable, so it doesn't have the self. Okay, so let's run this. Okay, and I'm going to print that as well at the end. So how do we print that? So we can try two different ways of printing it. Excuse me. Okay, so one way is actually right print. You can use the book object. Oh, not here. Okay, so book object, and let's say book one dot, oops, all right, library name. Okay, so also we can use book dot library name. Okay, so notice I use the class name instead of the object name. So that's allowed because this variable this variable is belong to entire class. Okay, so it's class variable. Okay, so I'm expecting both Fremont main. So it accessible both ways. Okay, usually we go for the class name and I use the dot notation to access it. Okay, all right. So okay, so next one, write another class to represent a textbook. So only added feature is the name of the subject. Okay, sorry. Yeah. Okay, so let's quickly add that, and then after I'm going to stop the recording. Okay, so right here, so I'm going to add okay, class textbook. Okay, and notice it's only extra that parameter, and then rest of the things I can copy it. Basically, I rewrite the code. That's what copy means, right? And I'm going to change by adding that the single parameter textbook. Okay, so right here I'm going to add subject. Okay, all right, and here it's textbook. Okay, all right, so textbook. Okay, and here we need to get that parameter. So self dot subject equals subject. Okay, all right, so that's all. Okay, so and then you should notice that. Okay, so imagine writing all new, so it's sort of like copy pasting. It's like repeating the code. So the question is, do we have to do that? And then that's going to basically that question going to be our next topic. Okay, so but anyway, let's create a textbook, and we can print out the name. Okay, so name of the subject. Okay, so let's add, before we do that, remember we saw the printing of the object gave some gibberish. Okay, so it's because this book object uses the object class string method which is basically the ID value and the some reference information of the object. But we need to basically print the printable value of the books, basically, text, um, description of the book. Okay, so that means we need to override str method. Okay, so let's write it over here. So right here, right here. Okay, so def str. Okay, and here we're gonna basically return. Okay, so the string representation of the book, basically we have to write, this is the title, this is the author, this is the ISBN, blah blah blah. Okay, only those data that save to write, print, basically. Okay, so we say, okay, um, the book, say the book title, and then we can write um, self title. Okay, plus author. Okay, and well, we can use plus this here too. Okay, plus excuse me, the author plus ISBN. So you can actually put equal sign over here. Okay, so BN, and that equals to ISBN. So that should be enough. Okay, so and that's, yeah, title, author, and ISBN. Okay, so this is sort of the string representation, so we are trying to put that. So this is usually come as a standard whenever we write a class to represent, whenever we write classes. Okay, so consider adding this method so that anyone can print an object, would get a good description about what this data is about. Okay, so otherwise, notice what the result we got. Okay, I think we printed, see that we get some gibberish, right? So it's saying the class, and it's running in main frame, and then the ID value. But this is not useful. Okay, so this should be about what this class, what are the data is about. Okay, so let's print this one now, and we'll see a much better. Oops, that was okay. I think this should be. Oh, okay. So I think, yeah, it should be ISBN. So I actually, yeah, this is an integer, so I need to convert this to string. All right. So run it again. Okay. So now see what we get. Okay. See that? The book title equals Python, author equals Brad Miller, and ISBN. So you need to actually put a space over here. Okay. So, and comma, maybe comma over here too. Okay. So print it again. So now it printed this good description about what is my object. Okay. So that's actually, that's, we basically override the string str method, and that gives basically a string representation of our object. Okay. All right. So I'm gonna stop our video, our lesson over here. So the next topic is basically the other rest of the concept. uh, starting from inheritance.